Hello everyone and welcome back to another LeetCode video. So today we're going to be solving the LeetCode question, partition array into disjoint intervals. Alright, so in this question we're going to be given an array called nums, and the goal is to partition it into two contiguous subarrays called left and right. So we have a few conditions, which is that every element in left has to be less than or equal to every element in right. And left and right are both going to be non-empty. And in this case, left has to be the smallest possible size. So we can have several different solutions to this, but we want the one where left is the smallest possible size. Now the goal here is to return the length of left after such a partitioning. And it is guaranteed that we have such a answer. So one quick thing over here is the fact that we have to have a minimum array size of 2 because we need two contiguous subarrays which are non-empty. So that is something that is covered over here. The minimum length is 2. And now let's just look at one solution to see how we can work on this. So this over here is one of the questions. We have 1110612. So let's just make a few observations. Now, one of the observations, so let's just look at the answer here before that. So over here, the length of L is 4, okay? So 1, 2, 3, 4, that's the length. Let me just change the color real quick. Sorry. Okay, so 1, 2, 3, 4. Okay, so this over here is the partition that we're making. So this, everything over here is the left subarray, and everything over here is the right subarray, okay? And let's just go to the checks real quick. Okay, they're both non-empty, obviously, and this is the smallest possible size left can be, and I'll go through that again. And over here, everything in left is less than everything in right. And keeping that in mind, we can actually come up with a simple observation. And that is the fact that left, right, since everything in left is less than right, left is going to have the minimum value for sure. In the same way, right is going to have the maximum value. So what's the reasoning behind this? It's pretty simple. Everything in left is less than or equal to everything in right. So that automatically tells us that the smallest value cannot be in the right value, in the right array. The same way, the maximum value cannot be in the left subarray. So that's why L is always going to have the minimum value and R is always going to have the maximum value. So that's one thing that we know for a fact. Now let's go on to a second observation that we can make. So over here, we have the values 1, 1, 1, 0, and then 6, 12 for the right subarray. So let's do the check, which is everything in left greater than less than or equal to everything in right? So the way, one simple naive way is 1 less than 6. And we keep doing that. Is 1 less than 6, 1 less than 6, 1 less than 6. Great. Okay, so now we're done checking for 6. So now we need to go on to the second second element in R, which is 12. So it's 1 less than or equal to 12. So we keep doing the check for everything in L. So this over here is going to be very computationally intensive. So one really simple way to look at it is, remember, L is going to have the smaller values compared to R, and R is going to have the greater values. So one really simple way to just check for everything, instead of doing this several for loops, we can just look for the maximum value in L and compare that with the minimum value in R. So what is the reasoning behind this? So like I said, L has all the small values and R has all the big values. So if you just take the smallest of R and the largest of L, and if the maximum value of L is less than or equal to the minimum value of R, that's the same as checking each value of L against each value of R. So in this case, let's just do an example. L is the largest in L, 1 is the largest in L, and 6 is the smallest. So in this case, 1 is less than or equal to 6. Great. Okay, so we have these two observations, and let's try to put that into a solution. So what I want to show you first is a solution that I kind of came up with, and why this may not be the best solution. So actually building upon this solution, we reached the final answer, but I just want to show you the solution that I first came up with and why it may not be that good. So what I did is I came up with a two-pointer method, which is I had a pointer which starts off at over here, so at the 0th index, and one which starts off at the very ending. So let's just call it L and R. Okay, so what's happening is that each time we move L and R to the left and right respectively until we have some sort of division. Okay, and now what are the conditions for the division? So one thing I'm using is the fact that left has the minimum value and right has the maximum value. So what I'm doing by default is I'm moving L to the minimum value by default. So L, in this case, the minimum value is 0. And by default, I'm moving R to the maximum value, which in this case is 12. So this is going to be our starting point. So that's a pretty good place to start. And now this is where it gets slightly complicated. How do we move L and R in this case, okay? So in this, actually, it works out pretty well. Remember this condition, which is pretty important. Left has the smallest possible size. So over here, we can either move L or we can move R. Now, obviously, we can't move them both because we can't have them at the same place. So we're only going to move one of them. And in this case, we're always just going to choose to move R. And the reason for that is because we want the smallest possible L size, right? So now we move R and we perform the check. And remember, the way that we're doing this is we're keeping track of the minimum R. So in the beginning, the minimum R, because there's only one value, is 12. And the maximum L in this case is 1, okay? And the condition applies, so we're good to go. So now when we move R to the left by 1, so R is over here, now the minimum R now becomes 6. So that's what we have, and the condition still holds true, so that's great. So in this case, we actually found a division because L and R are right next to each other. So we have a division here, and we return the length of L. So this actually works out perfectly, and this is what I did for my first solution. So let me just get rid of this. Okay, and you can see the code for this over here, but there's actually one place where it never worked out. So over here, I went to the smallest and largest value, and then I did the loop that I was talking about earlier, moving L and R. And like I said, I moved R first because I wanted the smallest possible L. So this is one test case which failed, okay? And let's just look. So the output I got was the index 7 for L and the index 10 for R. So this is the value 22 and 46. So this over here is slightly weird. And I use the same loop over here. But realistically, for our final answer, the L and R have to be right next to each other. But in this case, what happened is, let's just look at this. So the maximum on the left is 42. And the minimum on the right is 46. So let's say we move 62 over here, right? Now 62 automatically becomes too big because 62 is greater than the minimum on the right. So we can't do that. And if we move this to the left over here, we're going to have another problem because when we do that, we get 16. And 16 over here is too small. 16 is less than 42. So that over there is a problem by itself. So this actually is a problem, and we just get stuck in the while loop. So the actual answer over here was 11. So so what that means is that L had a length of 11. So this includes all of this array. So all of that is L. Now this is where the slight problem comes. So when we initialized it, L started off at the smallest value, which is 6, and R started off at the largest value, which is 100. Now by default, we always first moved R. And in this case, that actually did not work in our favor. So because of that, we had a problem and we weren't even able to find a solution. So we could actually rewrite this code to make this work, but it just becomes too complicated. So now let's look at a better solution that we can come up with, which is better than this as well. So for our actual solution, we're going to use the same idea, which is we're going to keep looking for the maximum in the left subarray and the minimum in the right subarray, and we're going to compare those two. And we're going to do this by keeping track of each of them at each instance. So what does that mean? So in this case, what that means is, let's look at the max of L, and we're going to create a new array, okay? So what we're doing is we're assuming that so this over here is our left subarray. So if only this value is part of the left subarray, what is the maximum in left? Well, it's going to stay as 1, okay? So we write 1. So now we're going to assume the fact where both of these are part of the left subarray. Now the maximum still stays as 1, and now we keep going on. So we assume 3 of these are part of the left subarray, so maximum is still 1. Now we have 0, so again the maximum stays as 1. But now when we go to 6, the maximum becomes 6. And now when we go to 12 as well, 12 becomes our maximum. So we have this one array over here, okay? So this tells us that given a left, so considering everything up to the certain index. So let's say we go to index 2. So let's say everything up to and including index 2 is considered as the left subarray. The maximum value is going to be 1. This is what it tells us. Now we're going to do the same thing, but for the right values, okay? So let me just use a different color. And we're going to find the minimum of the right values. So now when we're doing the min r, we're going to go from right to left. And the reason for that is because when we're going from left to right, for finding the max of the left subarray, this is how it looked like, right? So let's say we wanted the fourth index. We're considering this entire thing, right? From 0 to the fourth index. Now for the right subarray, we're going to consider from the ending to whatever index. So let's say we want something up to the second index, then we're going to go from the ending up to the second index, right? Here, right? So we're going from the right to left, pretty simple. Okay. So in this case, first we're going to have just the value of 12. So in that case, this minimum value is 12. We have no other option. Now we have 12 and 6. So in this case, 6 becomes the smallest, right? So now we go to 0 and 0 becomes the smallest. And now as we go to the left, whatever we do, 0 is going to stay the smallest. So this is going to become 0. This stays 0 and this stays 0. Okay, so now that we have these two arrays, our question is, how can we actually use it to actually solve our question? So the idea is going to be the same, right? So at any given point, max of L has to be less than or equal to the max R value, right? And keeping this in mind, what we're going to do is we're going to iterate through this array. Now the way that we're going to do this is for L, we're going to start iterating through the 0th index. But for R over here, so min R, we're going to start iterating at the first index. Now, why are we doing this? The answer is super simple. So if we're doing this, what we're assuming is we're making a partition over here. So what that tells us is that the 0th index, everything up to there, is going to be part of the left subarray, and everything, and for the right subarray, everything up to the first index is going to be part of that. Right subarray, the minimum value is 0, and considering that this is part of the left subarray, the maximum value is 1. And so we're going to compare these two values and with the same condition, which is max L has to be less than or equal to max R, okay? So in this case, it's not. So we're going to move it. So this goes over here and this goes over here. So in this case, same condition, 1 is not less than or equal to 0. So now we move both of them again. Same thing over here. 1 is not less than or equal to 0. And now 1 and 6. So over here, this condition is true. 1 is less than or equal to 6. So keeping this in mind, that means that we've found our solution. And what this is telling us is that the partition is right over here. And the reason for that, again, is it's telling us that the left subarray is going to be from the 0th index up to the first, second, third index, including the third index, and the maximum value is 1. And the same way, the right subarray is going to be from the ending up to this index over here, which is 0, 1, 2, 3, 4, up to the fourth index. And that value, the maximum value there, is going to be 6, and the condition is met. And one more thing, going from left to right this way actually ensures that we have the smallest value for the left subarray in size. So this over here is going to be our final solution, and the size of this is just going to be 1, 2, 3, 4. So we return the value 4. All right, so we're going to start off by actually creating our two arrays. So we're going to have the left array where we're going to get the max. So let's just call it L max, and we're just going to define an empty array. So we can just have them with nuns, and the length of it is going to be the same as the length of nums. Okay, and we're going to do the exact same thing for the right. So right, but except this is going to be right min, and same thing over here as well. So now we're going to have the first loop, which is going to be filling up everything for L max. So the way we're going to do this is we're first going to have a value called current max, and we're going to assume in the very beginning that the current maximum is at nums 0, right? And that makes sense when the left subarray just has whatever is at index 0. Okay, so let's have a for loop. So for x in range, length of nums. So over here, the first thing we're doing is we need to update current max if its value has changed. So current max is now going to be the maximum between current max itself and whatever the current value we're on is, which we get using nums x. Okay, so now that we have a new updated current max, this is going to be the value that goes into our left subarray, so L max. So L underscore max at the x index is going to have a value of current max. Okay, now we're going to do the exact same thing for everything in R min. So over here we're going to have a current min, and this over here is going to be the opposite. It's going to be the last value. So nums -1, and we're going to do the same thing. So for x in range, but now we're going to iterate it backwards. So length of nums minus 1, we're going to go up to the 0th index, so 0 minus 1, and we're going to decrement by 1 each time. Okay, perfect. So over here, we're going to do the same thing. We're going to update our current minimum. So we're going to take the minimum between the current minimum and the current value that we're on, which is nums x. So now that we have the updated minimum, we go to our min, go to the x index, and it's now going to have a value of current min. Perfect. So now we have L max and R min completely filled up. So the next thing to do, we have these two arrays, we just need to do the comparison step. And the way we're going to do this is by using a for loop. And remember, like I said, sorry, 1 second. Okay, yeah. So like I said, we're going to start iterating for max L at the 0th index, but we're going to start min R at the first index, okay? So keeping that in mind, one simple way we can do that is we can have a for loop where we start off at 0, but we're only going to go to length of nums minus 1, right? So we're going to go to the last but 1 value. And the way we're going to do this is that we're going to check if, so we're going to do L max, and L max, we're going to go to the index x, and we're going to check if this is less than or equal to R min, but this is going to be at the index x plus 1, okay? So this is the comparison that we're having, and at this point, if this condition is true, we have to get the length of everything in the left. And the way we get that is that's just going to be x plus 1, right? Because remember, we're going to the index x for the left subarray, and its length is going to be plus 1 since length starts counting at 1 while indexing starts at 0. So let's submit this. And as you can see, our submission was accepted. So hopefully this video was helpful, and thanks a lot for watching.